So usually we're used to the notion of solving linear equations. So for example, 2x plus 4 is equal to 8. We can solve this by subtracting 4 on both sides, right? And we get 8 minus 4, which is 4. So we get 2x is equal to 4. And then we divide by 2 to solve for x. So our answer here comes out pretty quickly as x equals 2. Now, a further step after this would be to solve quadratic equations. And quadratic equations simply means where the exponent of x is no longer 1 and it's 2 or greater. So now let's discuss exponents which are 2. So let's say we have 2x squared is equal to 8. Now this is also a pretty simple equation to solve because what we can do is actually directly solve for x by first dividing by 2 on both sides. So we're left with x squared is equal to 8 divided by 2, which is 4. And then we can do a square root operation to cancel the square. So we're left with x is equal to the square root of 4, which is plus or minus 2. Now the issue comes when we have squared equations, which means like x squared something, right? Where you can't directly solve for x. So for example, we can say we have, let's say x squared, I don't know, let's see, minus 2x plus 15, for example. And let's say that this is equal to 0. We'll say minus 15 actually. So to solve this, we now cannot just directly solve for x, right? If we add 15 to both sides, we're left with x squared minus 2x is equal to 15, and we still can't get x alone. So what we have to do is do something which is special, and it allows us to solve for x here, and it's called completing the square. And there are different ways to do this. There are different tricks to use to solve these indirect quadratic equations, but one of the main tricks is completing the square. Other ones you may have heard are factoring or using the quadratic formula, and others. So let's use completing the square for this one. So let's say we have x squared minus 2x minus 15, and this is equal to 0. So completing the square, essentially what we're trying to do is get this equation into the format of x plus some constant a squared is equal to some constant b, or some constant c. Because once we get it into this format, then we can just directly take the square root, right, of both sides, and then from there it becomes x plus a is equal to the plus or minus the square root of c, and from here we can solve for x by just subtracting a on both sides. So our goal again with completing the square is to get into this format. So let's talk about how we can do it. Once we have an equation in this format, what we do first is we add the constant to the right. So we add 15 on both sides. That goes away. We're left with x squared minus 2x is equal to 15. What we do here is we take the coefficient of the x term, we divide that by 2 on the side, so I'm going to do it right here, negative 2 divided by 2, and then we square that. So negative 2 divided by 2 is just negative 1, negative 1 squared is just 1, so that's 1. And this helps us determine what we're going to add to both sides to make this a perfect square. So that might sound a little complicated, but let's see what we're doing. So this is the value that we're going to add on both sides, determined by taking this and dividing it by 2 and squaring it. So I'm going to add 1 to both sides now. X squared minus 2x plus 1. And notice if I add 1 to the left, I have to add it to the right. So this becomes 15 plus 1, which is 16. Now, something really nice happens here. We notice that x squared minus 2x plus 1 is actually a perfect square. What that means is we can just rewrite this as x minus 1 squared. And the reason for this is because x minus 1 squared, here, let's do this on the side, is actually equal to that. X minus 1 squared is x minus 1 times x minus 1. We're going to do FOIL to confirm. We get x squared minus 1x plus 1. Minus 1x, that's negative 2x. We get x squared minus 2x plus 1. So notice that that's equal. So this is valid. We can rewrite it as that. And this is equal to 16. So now we're directly back to the format that we initially wanted to get to. So now we can simply take the square root of both sides, and we're left with x minus 1 is equal to the plus or minus square root of 16, which is 4. So x is equal to plus or minus 4 plus 1. And this is actually two answers, right? The first answer is plus 4 plus 1, which is x equals 5. Second answer is negative 4 plus 1, which is x equals negative 3. So we solved this equation, which looked unsolvable, right, with completing the square. And that right there, we can check our answer by plugging it back in to see if it's true. And that right there is completing the square.